In this video, I'm going to explain you about voltage and current sources in the subject of basic electrical engineering. So basically, we have two types of sources. Okay, one is ideal source and the other is practical source. So in this video, we are going to learn about these two sources and we are going to get four combinations I have written here. Nothing but voltage, ideal voltage source, practical voltage source, and ideal current source and practical current source. Like that, we are going to get total of four combinations, and let us learn about each of them in this video. So first, let us discuss about ideal voltage source. So ideal voltage source is nothing but the voltage source that will provide the constant voltage across the circuit for any changes in the load current or load resistance. See, simple. If you are making any changes in the load current or in the load resistance, see, we have the formula V is equal to IR, right? So what does it mean? Voltage, you'll be getting a potential difference is equal to, or voltage is equal to current into resistance. Current into resistance, if you do, you will be getting the V. So here the voltage source, that is nothing but V, is equal to IR, right? It provides constant voltage across the circuit for any changes in the load current or load resistance is nothing but this is a source voltage. Okay, from here the voltage is being generated. From this battery, the voltage is being generated. So here, and this is VL. VL is nothing but the voltage which has been generated because of the load current and the load resistance. Okay, this is load resistance RL, IL is load current. Because of the load resistance and the load current, whatever voltage is generated, that is the load voltage. So actually, if these are changed, because since VL is equal to IL into RL, if IL and RL are changed, okay, so current and resistance are changed according to the Ohm's law, then VL should also change. If I is equal to 2 and R is equal to 2, V will be 4. If it is I is equal to 3 and R is equal to 3, what is V? It has to become 9, right? But instead of that, even though you make any changes to the load current or load resistance, this VL will remain constant. Okay, the value of VL will not change. That is what ideal voltage source means. Got it? The value will not change even though you make changes to the current and resistance, and this will be always equal to the source voltage. Whatever source voltage is being supplied, the load voltage also will be the same. So VL is equal to VS. That is the case. Got it? So this is about the ideal voltage source. Ideal voltage source is nothing but a voltage source which will provide constant voltage across the circuit even if the current and load resistance are changed. Okay, so for this we have a graph. This is IL or RL and this is the voltage, load voltage, and at a point, that is here VS. So at a point of VS, VL will be equal to VS. That is why the graph will be straight line. That is, whatever changes you do to it, this will not change, right? So even if the current is 0 or the current is 1 amps or current is 2 or current is 10 amps, irrespective of the current or resistance, it will always be equal to VS only. Okay, and here we don't have the concept of internal resistance. Why I mentioned this is, in the practical voltage, we will be having internal resistance. Okay, so this is about the graph and the concept of ideal voltage. Ideal voltage is nothing but it is always constant. Next, let us move to the practical voltage source. So here in practical voltage source, basically, I have not written any definition for this. I'll tell you why. See, in practical, I'll explain you with the circuit diagram only directly. Here we have the VS, which is nothing but the source voltage. Okay, and here we have R, which is internal resistance. Okay, and I, the I is nothing but the current flowing in the complete circuit. And we have the load resistance and we have IL, load current, and because of this load resistance and load current, the VL is generated. VL is nothing but what? Load voltage. Okay, about graph I'll explain you later. Now let us see this. Now let us apply KVL in this loop. So what is KVL and KCL? I'll explain in the next video in detail, but for as of now, let us apply KVL. Okay, KVL is nothing but the sum of potential drop across the circuit should be equal to 0. That is mainly what KVL means. Okay, so how can we apply KVL? From here, let us apply. See, in this direction we are going. Okay, so positive to negative you have come, right? Positive to negative, if you're coming, then you have to consider it as negative. Okay, see, if you're having any if you are having any confusion, do not worry. I'll explain you KVL, KCL in separate videos. I'll also explain you with example problems. Okay, Now, so what you'll get, minus IL RL. Why minus? Because from positive to negative you are coming. Okay, next come here. This way we are coming, right? So once you come here, it is also going from positive to negative only. Okay, and what is the current we have here? IL. IL is only passing here, not I. Okay, so it will also become minus IL into small r. Okay, next, this is going from negative to positive, right? Negative to positive, so you can consider it as plus Vs. Why Vs? KVL means what? The potential difference, the drop potential difference, sum of potential differences should be equal to 0. So this is potential difference only. IR into R is potential difference. V is equal to IR, right? IR again. So this should be equal to 0. Okay. Now what we will do is, IL, RL is nothing but what? VL, right? IR. V is equal to IR. So VL is equal to IL, RL. VL is equal to IL RL. Why? Because V is equal to IR. Since it is load voltage, it will be equal to load current into load resistance. Okay, this will become minus VL minus ILR plus VS. Okay, now let us send these two things, or let us send VL to this side, is equal to 0, right? Now what we will get, VL goes to that side, you will get VS minus IL into R is equal to VL, right? So wait, Vs minus IL into R is equal to VL. Initially, in case of ideal, VL is directly equal to Vs, but in case of practical, what is happening? VL is equal to Vs minus, you are subtracting some amount of voltage. Okay, and what is that called as? It is called as the drop, and that is represented here. ILR is the drop. Since you are subtracting this ILR from Vs in order to get VL, this is called as the drop. Okay, and the graph will be in this way. Vs minus IL into R is equal to VL. This you will be getting on applying the Kirchhoff's voltage law. Okay, done. I hope you guys are clear. So here we have the concept of internal resistance, whereas in case of ideal, we don't have the concept of internal resistance. So in real time, when you are implementing things really in practical, this only will work. Ideal situation is just to discuss, is just to explain, but ideal situation will not really exist in the real world. Okay, so if you want to make this as an ideal scenario, what you have to do, put R is equal to 0, small r, internal resistance is equal to 0, then this will become 0, right? This complete term will become 0, so Vs is equal to VL you will get. Okay, so this is about voltage. Next, let us discuss about ideal current source. Ideal current source also same. It gives the constant current. Here instead of voltage you will have current here. That's all simple. Apart from that, nothing. It will give the constant current in the circuit even when the load is changed. So even when the load resistance is changed also, it gives the constant current. In voltage source it is giving the constant voltage, right? But here it is giving the constant current. See, actually VL is equal to IL RL, right? So IL can be written as VL by RL. So usually when RL keeps changing, IL also have to change, right? But in case of ideal current source, it is always giving constant. This ideal current source will always give the constant current irrespective of the changes done to the RL. Okay, again the graph will be same way. IL is equal to IS, no changes in the graph. Now let us say practical current source. See, in practical current source you are applying Kirchhoff's current law. You are not applying voltage. Since it is current, you are applying the current law. In voltage we have applied the voltage law. Before that, let us try to understand the terms. So this is source current. Here also source current only is flowing. It is node X and load current. This is load resistance and this is load voltage which is generated because of this IL and RL. This is internal resistance, small r, and IR is the current which is generated because of this internal resistance. Okay, now what we will do is, let us apply KCL at node X. At node X, let us apply KCL. Sum of incoming currents is equal to sum of outgoing currents, KCL means. Or you can also say that sum of all the currents at a junction will be equal to 0. Anything you can do. So now At this junction, what all currents are coming, we have to see. Okay, is equal to, this is the incoming, right? This is coming inside, and this is outgoing because it is going, this is out, and this is also going outside. So obviously is sum of incoming currents. Incoming is is, so is is coming here, and what currents are going away from this node X? IR is going away, IL is going away, so these two are outgoing currents. So is equal to IR plus IL. That's all, very simple. Okay, so from this, what IL you will get is minus IR is equal to IL. IR is nothing but IR. V is equal to IR, right? So I will be equal to V by R. So V is nothing but here VL. What voltage is there in this loop? In the current complete circuit, we are having only one voltage, VL. So VL by small r. Is minus VL by small r is equal to IL. This is the equation we get for practical current source. Okay, so in ideal current source, what we had, IL is directly equal to is, but in practical, IL is equal to is minus VL by R. So what is the drop here? VL by R is the drop. Got it? So this is the graph. IL, RL, you are drawing the graph, and at this point IL is equal to is, but gradually it keeps on decreasing with a drop of VL by R. Okay, in order to make this one as practical, what you will do, in voltage we took R is equal to 0 to make it as practical, but here what we are taking R is equal to infinity. Why? Because VL by R, right? If R is equal to 0, what will happen? It becomes infinity, which is not valid. So that is why instead of 0 we are taking infinity. Anything by infinity you will get 0, so that this term will become 0, and here automatically is will be equal to IL. Okay, this is how we do ideal to practical in case of voltage or in case of current. Okay, in the exam, if you are asked about ideal voltage and current sources, you can write about these 4 cases. Okay, I hope this video helped you. Thanks for watching the video till the end, and if you're still having any doubts, let me know in the comment section. I'll definitely try to clear. Let's meet up in the next coming video with another topic. Till then, stay tuned to my channel for more such videos.